We're going to now walk through an example where we're going to solve a system of first-order linear differential equations for the case where we have repeated eigenvalues. We're going to find the general solution to the system of equations dx dt is equal to 5x minus y and dy dt is equal to 4x plus y. The first thing that we want to do is we want to write this system in matrix form. We're going to let x be equal to xy, and this gives us the derivative with respect to time of xy is equal to 5 minus 1, 4, 1. That's just separating our constants from our x and our y, and we're going to multiply that by x times y. We can then write this as d vector x dt is equal to a matrix A times x, where matrix A is equal to 5 minus 1, 4, 1. In step 2, we are going to find the eigenvalues. These are the eigenvalues of our matrix A. There are two ways that we can find them. The first way is to solve the determinant of A minus lambda I is equal to 0. And then the second way is to solve it using this equation. Lambda squared minus the trace of A times lambda plus the determinant of A is equal to 0. We'll solve it both ways. Let's go over here and do the determinant way first. We're going to take 5, and then we're going to subtract lambda off the main diagonal, and then we have a minus 1, 4, and then we have a 1 minus lambda, and that's equal to 0. Multiplying the main diagonal entries, we have 5 minus lambda times 1 minus lambda, and then we subtract off our off-diagonal entries, minus 1 and 4, and we multiply those. This gives us lambda squared minus 6 lambda plus 5 plus 4 is equal to 0. This gives us lambda squared minus 6 lambda plus 9 is equal to 0. Before we go to factor this, let's go over here to the right and let's do it the second way. This gives us lambda squared minus the trace of A. Here's what the trace is. You take the diagonal entries and you're going to add them. So this is 5 plus 1 times lambda, and then for the determinant, you multiply the main diagonal entries and subtract off the off-diagonal entries multiplied. This gives us lambda squared minus 6 lambda plus 9 is equal to 0. This way is probably a little bit quicker, but it does have a drawback because you have to remember what that equation is. Let's now go down here to the left and let's factor this and find lambda. We can write this as lambda minus 3 times lambda minus 3 is equal to 0, and we get lambda is equal to 3 and 3. Before we go on to the next step, let's make a note at what type of eigenvalue we just got. The eigenvalues in this example are called repeated eigenvalues. This is going to tell us what our general solution is going to look like. In step 3, we need to find the eigenvector associated with our eigenvalue. Let's just make a note that our eigenvalue is lambda is equal to 3. To find the eigenvector, we have to solve the system of equations A minus lambda I times V is equal to 0. Let's also put over here what our A was. From our last page, it was 5 minus 1, 4, 1. And then we're going to let vector V be AB. We're going to subtract lambda off the diagonal, so we get 5 minus lambda minus 1, 4, 1 minus lambda, and we're going to multiply this by vector v, which we just saw was AB, and it's going to be equal to 0 on the right-hand side. Now we're going to substitute in that lambda is equal to 3. So we get 5 minus 3 minus 1, 4, 1 minus 3, and we multiply this by AB, and it's equal to 0. This gives us 2 minus 1, 4 minus 2, times AB is equal to 0, 0. We can solve this using linear algebra, and we can also solve it just using regular algebra, and I'm going to solve it using regular algebra in case you haven't had linear algebra yet. This gives us 2a minus b is equal to 0, and then we have 4a minus 2b is equal to 0. These are the same equation. I'm going to solve this for a because I think that's going to be easier. A is going to be equal to b over 2. Now we get to choose a value for b. So I am going to let b be equal to 2. And the reason I'm doing that is that makes a equal to 1, which is really nice. Our solution then, our eigenvector, is equal to ab. And now we can plug in that this is equal to 1 and 2. We're going to need that in a minute, so let's go ahead and let's highlight that. Now let's go to step 4. Step 4 is to find what's called a generalized eigenvector. And that generalized eigenvector we're going to call vector w. So we're going to solve the system of equations a minus lambda I times vector w is equal to vector v, and vector v is the vector that we just got. So let's write this down. A minus lambda I, that's just what it was before. Let's go up here and I'll show you where that comes from. It is right here. So we have 2 minus 1, 4 minus 2, and now we're going to multiply this by w. So I'm going to call the components of w, w1 and w2, and it's equal to vector v, which we just got, and that's 1, 2. If we convert this to an algebraic system of equations, we have 2w1 minus w2 is equal to 1, and then our second equation is 4w1 minus 2w2 is equal to 2. Notice that these two equations are the same. So what I'm going to do is I'm just going to solve this first one for w1. w1 is going to be 1 plus w2 all divided by 2. Now we get to pick what w2 is. Let's see what we can choose so that we don't have fractions. I think we could let w2 just be equal to 1 and everything will work out nice. We're going to let w2 be equal to 1, and that's going to give us that w1 is equal to 1. So we have our generalized eigenvector, vector w, was equal to w1, w2, and we now know that that is equal to 1, 1. And we'll highlight that one. Now in step 5, we can just write down the general solution. Over here on the right, I wrote down what the general solution looks like when we have repeated eigenvalues. Our lambda is up here in the exponent, and then we have our eigenvector v, and then our generalized eigenvector, vector w. Our solution then looks like this. We have x of t is equal to c1 times vector v. Let's go back up here and grab that. It is 1, 2 times e to the lambda t. Lambda was 3, so we have e to the 3t. And now we're going to have a c2, and we're going to have our vector v again, 1, 2. That multiplies t. And then we're going to add on our vector w, which was 1, 1. And all of this gets multiplied by e to the 3t. And there's our solution.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.